know once you will be able to see my presentation.
Yes, we can see.
Okay, awesome. Let's make a screen in such way. Okay. So, this is thank you. The first thing, like, thank you everybody for joining. And actually, this is like a small anniversary for me because it's a 10th session at the community. So I hope that we will spend this 1 hour, probably 1.5 hours, and this will be useful for you. Today we will talk about the Kubernetes policies, why we actually need this, how this works, and like how to implement this. I was trying like to perform this presentation to be short, but we will spend less time for the theoretical stuff and let's like spend more time for the playground. Okie dokie. So the short agenda here. So we will talk about the Kyverno. So I'm not sure like about the pronunciation because there are a lot of video from the Indian contributors and they pronounce like this this title in like different ways, but from the native speakers I heard that it's called Kyverno. We will talk like about the architecture, compare it with some alternatives, take a look on the main ecosystem and the components, meet how to work with the policies, and perform some implementation demo. So I'll show you how this can be how this can be completed. So before we start, let's understand like why we need like the policies for Kubernetes. Let's imagine that you have like a lot of clusters under your control and a lot of contributors and users in these clusters. You need to make sure that everybody performed just those actions that is probably allowed. Yeah, and you won't probably disallow some actions, or you have some requirements for example, to the resource naming or resource labeling, or you want to automate some actions or automate the provisioning of some resources. So in this case, you need policies. Policies also help you to monitor the health of your cluster and check how your cluster and the resources in your cluster matches to some predefined rules. Yeah, so you will be able to understand what is happening in your cluster, and what is wrong, and what is performed in the right manner. And additionally, this gives you ability to perform inject or integrate some approval mechanism to your cluster. So you know how to work with RBAC, but RBAC are probably has like primitive manner. Like they just allow us to do something, but we cannot like perform the deny of some actions. So for this case, the policies will help us. So let's talk about the Kyverno and what is that. So the Kyverno, it's like set of the tools that help you to implement policy as a code for the Kubernetes stuff. Traditionally, it's the Cloud Native Compute Foundation product, but it's in the incubating stuff. This product was started at, I think it was started in the 2019, and actually it's incubating, but it's like production ready, so you can easily implement it for your prod environments, and no needs to worry about like if something will happen. How it works? So like some systems like Istio, for example, has like a set of the microservices that perform some actions, yeah, for that tool. The same for the Kyverno. So we have a set of the controllers in our ecosystem, and those controllers perform some specific actions. So how the this policy mechanism actually works. For example, you create some API request. It probably can be like apply of some resource or update of some resource. You send it to the Kubernetes API. So the Kubernetes API server component will perform the authentication and authorization. And after that, it sends like your request will be interrupted and it will be sent to the admission controller of our Kyverno. And this admission controller will perform the policy applyment to the incoming request. Yeah, for example, you want to create some deployment and you have some policy that like doesn't allow the deployments with images that contains the latest tag. Yeah, so in this case, the admission controller will check your request, understand if you have such conditions like latest tags, and if something is wrong, it will send back the rejection. So in this case, you won't be able to create the resource. So this is a great mechanism that allows you like to control what can be happened in cluster and what cannot be. Once you passed the rules, after that, the schema validation will be performed. And one more set of validation admissions. Yeah, so here we have the mutations. Yeah, and here we have the validation. So the validations is probably if you want to check something, and the mutate if you want to perform the patch of your request and like change it before it will be applied and stored in the cluster. So once all of the data is mutated and validated, if everything is fine, it will be written to the etcd, and so your resource will be ready for usage. Now we have a set of the controllers, as I mentioned before. For example, admission controller is responsible for the mutating and validating stuff. So it will apply the mutation and validation rule types. Beside it, sorry, we have the cleanup controller. So the cleanup controller allows us to perform some cleanup policies. So it's like automated policies that helps you like to automatically clean up unneeded resources. Also, it has the report controllers that will collect the information about the rules and the policies, and will generate some reports that will be actually suitable for you. Background controller works on the scanning of the existing resources, because in case of the admission controller, it works only with like the fresh resources and like fresh queries. So the background controllers will also examine the existing resources. So we will, like during the implementation demo, we will check how this can be done, yeah, for the new resources and for the existing resources. And there is also the cert renewer, but it's not the separate controller. It's actually the part of the admission controller, because the admission resources in the Kubernetes requires the HTTPS. So all of your controllers must like provide some specific API through the HTTPS, and this cert renewer actually will care about the about your certificates. Beside that, we also have the policy exceptions. So the policy exceptions allows us actually to make exceptions in the policies. Yeah, for example, you apply all of the policies to some specific set of the resources. With the policy exceptions, we will be able like to configure which resources shouldn't be validated or mutated. So one more image that describe how actually it works. Yeah, it's like a simpler image. Yeah, so you send some data to the Kubernetes API server, and the Kubernetes API server will send, like before applying to the etcd, it will send everything to the Kyverno. So Kyverno will apply all of the policies, generate the reports, and then just send the response back to the API server. So, and after that, API server will care about that resources. So actually it's a native way how the Kubernetes works. So it's not something like a bicycle. Yeah, it's like how the Kubernetes allows us to modify and extend the behavior of the API server. So about the alternatives, so something wrong with the image here. So here it must be Kyverno. Here must be, so probably let me check this slide in such way. Let me represent probably. Okay, I'm not sure why it happens with let's take a look on it in such way. So we have the open policy agent and we have JS policy. Yeah, so it's like the main competitors and alternatives for the Kyverno. So now let's try to compare the main competitors like Kyverno and the Gatekeeper. So for the the main difference is that the Kyverno allows you to perform some generation rules. So for example, you want to generate some, like automatically provision some resources like secrets or the config maps. So in this case, you are able to perform this with a Kyverno. Like the image verification, actually, this process is related to the verification of the image signatures. So this can be done with the Kyverno, like in the native way, with the Gatekeeper. Actually, by default, it's impossible, but you can add some extension that will allow you to perform this. Actually, I need to mention that the Gatekeeper is also the Cloud Native Compute Foundation project, but it's the like already graduated project. It was based on the open policy agent. So the open policy agent, it's like not the Kubernetes native tool. Yeah, it's mostly like the tool for the policies for everything. Yeah, and the Gatekeeper just use the open policy agent and like use that framework to apply these rules to the Kubernetes. So the open policy agent, it's like not the direct solution for the Kubernetes itself. One more thing, it's like the reporting stuff. So the Kyverno allows you to gather the reports based on your rules and also configure the alerting based on your rules and etc. One more important thing, it's the image registry lookup. So the Kyverno allows you to gather the information from the image registries and use that information in your rules. Yeah, for example, like you want to automatically like change the tags in your like pod definitions to the digest of the image. So you can gather the digest from the image registry and like use it in that rule, and that rule will like replace the tag with a digest. The bad thing is that the Kyverno has no ability for the extension, but you will see like during the demo, you will see that like it has all of the features and it probably can cover everything. Yeah, so it's like has different mechanisms and like different languages can be used inside of the Kyverno, like to operate with the data and write like rules of the different complexity. One more image that is related to the Kyverno stuff and open policy agent and also JS policy. So the main difference is like that the Kyverno use the YAML configurations. The open policy agent use the language that is called Riego. Actually, when you use the Gatekeeper, so in case of the Gatekeeper, it transform your YAML to the Rego. And like in this case, like the Gatekeeper like it's also like native tool for the subtool, yeah, for the Kubernetes, so you won't be need to operate with Rego. But if you want like use directly the open policy agent, then you need to learn Rego. For the JS policy, you can use the like all the policies will be written with a JavaScript. It has some benefits like you can extend and write any kind of policy, and you can use different packages and etc. From the disadvantages, for example, for JS policy, there is no image verification. So, and actually all of the metrics from those three solutions are performed like can be collected with a like standard Prometheus Grafana stack. Now let's move to the Kyverno components. So I'll briefly describe how those components works. Yeah, so the admission controller like is responsible for like mutating and validation of the request to the Kubernetes API. The reports controller will generate the reports and perform the all report processing logic. The background controller is responsible for the generation rules and also for applying of the mutation for the existing resources. And the cleanup controllers, the controller that allows you to set up the cleanup policies. So here we have a set of the, like on these slides is presented the main functionality of each controller. So I won't spend like the time for that, but if it will be interesting for you, we will share the presentation and you will be able to meet with it. Like, what about the phases of the admission controller? Yeah, so this image actually describe how this performed in the Kubernetes, but also describe like the main Kubernetes resources that is involved in this process. Yeah, so we have the mutation admission controllers resources, validation admission controllers resources, and it operates with a webhooks. So it sends these webhooks to the Kyverno ecosystem. So and once it's done, it's sent to the etcd. So in this part is described the authorization and authentication. So I just added this image like to demonstrate how it's related to the Kubernetes resources itself. Also, we have the report controller here. So I probably will spend the part with the controller stuff. And let's go to the basics. So how the policies looks like and which type of the policies we have. So we have two type of policies. We have a cluster policies and actually just a simple policies that are namespace level resources. So the simple policies are applicable only for the resources in the same namespace, and the cluster policies will be applicable for all of the resources inside of the cluster. So each policy has a set of the rules. Each rule has some selector section that can contain match conditions and exclude conditions. So with like this selector stuff, we will select to which resources in your Kubernetes or like to which resources that will be created you want to apply this rule. So each policy can contain just one rule or the multiple rules. And the rules will be executed consequently, yeah, like one by one. So in like when you will write the manifest for your policies, just take care that you added all of the rules according to the like with the right order. Once you write all of the conditions how to select the resources, you will be able to choose the type of the rule and then describe how this rule can be done. So for the validations, a validate rule and etc. For the mutate, the same, and for generate and for verify images. So the cleanup policy, it's actually the separate resource. So it will be described with the cleanup policy kind. We will see the example how this can be done. And the same for the policy exception. So the policy exception, it's a separate resource. And actually it's a only namespace level resource. So the policy exception allows you to accept the rules only for the resources in the same namespace. So here is described the type of the rules type of the policies, sorry, that we will be able to perform. And probably let's do not spend the time for it. If it's interesting for you, just read it in the background. One more important thing, before we will start the practical part, it's the verify image rules. So the verify image rules has a little bit different structure, rather standard generate or mutate or validation rules. The verify images rules can gather the information about your image that you use in your workload, and then can apply a set of the attesters. So what is the attesters? It's type of the examination that will be applied to your image. So which type of the examination it can be. For example, you want to check the signature of your image. So usually the images can be signed with a notary or Casign compatible mechanisms. And usually this signature is stored in the same OCI registry. So when you push your image in the Docker Hub, you probably cannot see this in the UI, but actually the information about the signature of your image will be stored. So you can just, beside of the pulling of your image, you can also pull the signature. So based on that, the Kyverno allows you to verify the signatures. And in some cases, for some specific tools like Trivi, it also allows you to make the verification of the security scanning reports. So I'll show you some example how this can be done. Let's imagine that you perform the scanning of the image with Trivi. So Trivi allows you also to push the scanning report to your repo. So, and the Kyverno will just gather this report from the image registry, and you will be able to make the validation. So you will get the access to the content of this report. Yeah, for example, you can write some policy that will validate if there is no high severity vulnerabilities in your image, and for example, block the creation of the workload that is based on affected version of the images. And I think we can just went out to the implementation demo. Just give me one more sec. I'll okay. So for our purpose, I deployed a simple Minikube cluster and already set up some monitoring stuff. Let's start with the simple things that is probably not related to the rules. It's the monitoring stuff. So the Kyverno itself and the controllers generate a portion of the metrics and traces. And if you use the Grafana stack together with the Prometheus and some tracing tool like Jagger or Zipkin or Tempo. So in this case, you will be able also to see how the request is proceeded inside of the controllers. For example, go to the monitoring stuff. So I prepared all of the scripts with a playground, so we will be able also to just repeat everything after the session. So let me open the local Grafana. I don't think that the presentation will be needed for us, so I can just close it. Once you install the, if you already have the Grafana and the Prometheus operator, so once you will install the Kyverno, it will automatically provide the dashboards with all of the metrics. So you will be able to see how many policies you have, how many like admission requests you get, like your Kubernetes API server receives, and how actually the process of the policies applyment works for you. So in most of the cases, you will be need to check like the set of like amount of the policies that were failed and the policies that contains the warnings. So probably it's the useful stuff. If you will deep dive, so in this case, you can just check like the set of like the amount of the rules, like and deep dive on how these rules proceed over the time. Let's do not spend the time, but just you understand that you can just gather all of the metrics information automatically, and this will be useful for you. Beside the metrics for it, we can just explore some portion of traces. Yeah, so I will search. So I can just select the admission controller or cleanup controller, like the appropriate controller version. Let's take a look on the admission stuff. And let's check what we have here. So we have a different operations here. Yeah, like with a, like mutation policies. And we can just verify. Okay, so there is no policies here because I performed the cleanup before. Let me think what can be useful for us. Okay, so you can check probably the rule stuff. Let's take a look on the last 24 hours. Okay, find the appropriate trace, and for the rules you can like see the like duration of your rules, and you will be able, for example, you have the policy and you can see how many time takes each rule. So in this case you will be able to make the like troubleshooting and the optimization of your rules. If you see that the rules is slow, you can just like disable that rule, or you can just try to override it. But usually it's pretty fast, so you don't need to care about this. But if you see that something is slow, so with the tracings, and traces actually populated also automatically if you have the Jagger installed. So in this case, like you will be able to understand what is happening inside of your Kyverno controllers. And one more important observability, it's the log stuff. So you can set up the logs collection for each controller. For example, I don't know, let's take a look on the background controller and check the logs for the last 24 hours. Okay, here we are. So the logs from the controllers are like well structured. So in this case, you can just additionally apply some extra parsing rules if you wish. But if something happened like with your policy or something is wrong, you will see this in the logs. So logs actually, based on these logs, you will be able to create some extra alerts with Grafana, and if something like will happen with your policies, you will be also able to troubleshoot and understand what happened. So it's from the observability stuff. Now we are probably ready to check the check the examples of the rules. But before we start check the examples, I will show you one more thing. So the Kyverno itself, beside the controllers, also provide the Kyverno CLI tool. So this tool allows you to make like the local test of your policies. For example, you can pass to this tool like the manifest with your policy and manifest with the resource that you want to create or update. So, and in this case, this tool will perform the dry run and will demonstrate how this policy and how the rules of this policy will modify your manifest. If something is wrong with your policy, you also will see it. So before applying to the cluster, I strongly recommend you to just validate the rules with the CLI. One more possible way how the contributors of the Kyverno recommends to use it, it's just one more sec, please. It's integration of this tool to the continuous integration system. For example, you want to like you develop some Helm chart, and like you want to make sure that this Helm chart is matches all of the policies. So you can in the CI system you can use the CLI and validate if the like the manifest from your Helm chart matches the policies. Yes, please, let's go with the questions.
Yeah, I have a small one. So does this dry run works in a similar fashion that kubectl dry run? So does it have like only client side or client server side, or it's just like manifest validation?
Okay, gotcha. It's a good question. So you can work with like the main confusion is that like the tool that is like the command that is used for the validation of the rule is called apply, but it actually do not apply the rule to the cluster. So with this command, you are able to test your policy against the like resources, like your local resources in the files, or you are able to perform the test of your policy against the existing resources in the cluster. So in case if you like don't have the connection to the cluster, you are able to validate the policies based on the manifest locally. If you want to check how it will act with existing resources, just like do not pass the pass to your manifest, local manifest, and just use the cluster key. I'll show you how this actually works.
Yeah, so it can do both essentially.
Yep,
Okay,
yep.
thank you.
And actually, it works in the same way if you want with Git repos. Okay, so let's then start on the examples. And probably we will start with the resource selection. So as I mentioned before, so I prepared a set of the policies, and like in each example, I just demonstrated a different way how this can be achieved. For example, this cluster policy will be applied to the new resources. Actually, this is the namespace resources. We can define actually the template, like the actual names of the resources that we want to apply the policy. or we can use just the wildcards. So wildcard can be used with the star or with the question mark. So the star means like mm, as many symbols as possible, and if you want just to wildcard with a single resource, yeah, single character, sorry, then you just can use the question mark. So in this case, like for example, team A will match this rule. So in this case, the name of your namespace should looks like here, like this. After that, we can just add the set of the operations to which this rule will be applied. So this is actually optional field. You can just actually the minimal set of the match section can be just like with the kinds, but you can use also the set of the operations. Yeah, for example, I want to apply this policy only once the namespace resource is created. So if you don't use this operation stuff, by default, it will be applied to the create and update operations. So if you want just to apply it to the specific one, then just define it in your policy manifest. Beside of the resources, you can just also control the set of the subjects, roles or cluster roles. Like, for example, you want to apply this policy only in case if some specific service account or some specific user like make this request. I think I have some example here. Yep. So here I have example, but it's not with the match section, but with exclude section. As you can see, I use a different operation. So I will deny the deletion of some specific namespaces, but I exclude the behavior of this rule for specific cluster role. So if you act as a cluster from the cluster admin role, so in this case, this rule will be skipped for you. So it means like only the users with cluster admin role will be able to delete the namespace. For the rest of the users, once you will try to perform the deletion, for example, with the kubectl, the Kubernetes API will return some specific message. So you can define the message actually here in the rules. Let's get back to the matching section. So beside the like name, you can also use the like if it's some like namespace based resources, for example, deployments, you can also define an actual namespaces where this kind of resource will be looked up. Also, you can select your resources by the labels, and also like the namespaces of your resource also can be selected by the labels. So it uses the standard Kubernetes mechanism. You can use the match labels or match expression if you want like to use like different operators like in, not in, and etc. So this can be detailed checked in the documentation. And as you already saw, so you have you are also allowed to exclude some resources. For example, you match some namespaces here, and you also want to exclude some specific resources. Yeah, so I write resources kinds, namespace, and sorry, it's incorrect. Like this. And the names, For example, I just want like to disable this rule for the namespace with a specific pattern, like team, prod, and wildcard. So in this case, if my the exclude rules take precedence over the match rules, so even my namespace that I want to delete will match this pattern, but it will be excluded because it also matches this pattern. Yeah, for example, if it's a team prod A, so in this case, this rule won't be applied. Okay, I think we are good with that. Then, beside like in the matching section, you can also use some variables mechanism. For example, you can make selection with the labels. For example, select match label, something like this. Let me add it somewhere here, something like this. Okay, so I will delete this part and just will perform the selection only with labels. I can use the variables. So the policies in the Kyverno use the mustache syntax like it's performed with a Helm. And also it allows you to use GMS pass like engine for modification and like selection of the manipulation with the data. For example, like there is a set of the predefined variables, for example, request variable. So it contained all of the information about the request. Yeah, and in my request, I have the object that will probably be applied. Now I can go with the fields. Yeah, for example, metadata and name. So once this policy will be evaluated, so this placeholder will be automatically replaced with a name of the resources like that will be created. But there is some set of limitation here, and the main limitation is that in this selection, like in this match section, you are able to work only with like the data that is stored in the metadata field, like name, namespace, labels, or annotations. If you want to make like a deeper selection of your resource, you can additionally use the preconditions, like here. So this is not a great example, but I will explain you why it looks in such way. So for the additionally to the match section, so I match all of the deployments and I perform the create and update operation. So I check if the namespace for this resource like matches the pattern. I actually can also make something like this: request object spec replicas, and use something like greater than, and here write something like 3. Yeah, so in this case, it will be applied only to the deployments that has more than 3 replicas. So there is a set of the operators here. So I will just refer to the Kyverno documentation. Set of the operators for like any kind of condition. Yeah, for example, you can just compare the numeric values, or you can compare the duration, or you can just check the arrays, and etc., etc. and the vice versa rules like not in, not equals, and etc. So the preconditions can be actually used for, can be described for different type of data that is related to your resource. Let's rotate this because we will be needed in the future. As you can also see that once we perform the like match and when we perform the precondition, we have this any keyword. So this can be any or it can be all. So in this match section, you can define a multiple matching filters. So in case of the all, so it means like that resource must match all of the filters. In case of the any, it means like resource must match any of these conditions. So the same for the precondition. So for the precondition, you can just select any, or you can just set it to all and write multiple preconditions. So I think that's all for the selection of the resources. Now we can just write a different type of the rules. For example, validation rule. For the validation rule, we the first thing that we need to do is just write the failure action. The failure action can be enforce or audit. So once we set it to the enforce, it means if the resource doesn't match this validation rule, the creation or like the request will be rejected, and you will see it like in your kubectl or somewhere else. In case of the audit, so the resource will be created, but the information that this resource doesn't match this rule will be stored in the system, and you will be able to see it in the reports. So if you want to strict rules, then just use the enforce. What they recommend to do is when you develop your rules, for example, validation rules, start with the audit stuff. Like test your policies with the CLI. After that, apply it to the cluster with the audit type and check how it behaves. Once you will be 100% sure that it works as expected, then just switch it to the enforce. And like, I think this process will work fine. You can additionally add, for the validation rule, you can add the message that will notify the user why his request is rejected. So it's a message that will be demonstrated in case of the failure. And the pattern actually it's like a subset of the data from the resource that must match. For example, you create the namespace. So in the metadata labels, you must have the label that is called purpose, and it contains the team value. So if your resource doesn't match this pattern, so in this case, your rule will be failed. Beside the pattern, you can if you want to apply it like different patterns, you can use the any patterns and define the multiple patterns. If your resource match any of it, so this rule will be passed. If not, then it will be failed. That's actually all about the validation rule. I think I forgot something. No, it's not all that. Beside the like pattern matching, we can perform the deny rule. Yeah, for example, here as I just demonstrated, the deny rule allows you like to deny the operation to the resource. Yeah, for example, namespace, delete request for some specific namespace. And we deny if the condition matches. Here we can use also any or all. So it like this section actually looks like the preconditions, but it's called conditions. Yeah, but it uses the same operator and etc. And we check if this condition like matches, then this deny rule will work. So we check the request operation. So the operation in our case here will be delete. If it's equals to delete, it means like this rule will pass to. It means like it will deny the request. So it's how this deny mechanism works. We can also write the validation rule in a little bit different manner with CEL. It's the common expression language from Google. Just let me show you what is that. So it's a separate project. And it allows you to perform the modification of your data. So if the GMS path is not enough, you can use the CEL stuff. Or if you want to write some specific validation policy with specific logic, the common expression language will work for you. For example, you want to check if your deployment contains not more than 4 replicas. So you can write the CEL expression here. And additionally, you can add the message that will be thrown if this condition is not matched. So in our case, if you remember, I described some policy example about the deny latest stack. So I use the complex expression. So I refer to the object that will be created or updated. So I will go to the specification. Like in my case, it's a deployment. I will go again to the template, specification, containers. And after that, as the containers is actually array, I can just apply the all function to this array. So the basic element will be container and my condition will be here. So I check if the container image ends with latest. So all of the functionality for it, you can check in the guide for the common expression language. So it has a lot of different functionality, and you are probably can write anything with it. And in case if this expression doesn't work, so if any of the containers in my deployment has the image that ends with latest, so this rule will be failed. But in my case, I do not enforce it. I will just perform the audit. So once I will apply this rule will be applied to all of the resources, existing resources and actually new resources. If I want to apply the rules only to the new resources, on the policy specification, I will need to change the background false. It means that this policy won't be processed by the background controller, and this policy will be applicable only for the new requests. Yes, for the create requests or for the update requests, but it won't be enforced for the already existing resources. And I think on this point, we are good with the validation rules. We can went out to the mutation rules. So the mutation rules allows you to change the resources on fly and apply some patch strategic merge. So if you are familiar with customize in the Kubernetes, so it works in the almost in the same way. So you can use the patch strategic merge, or you are able to use the JSON 6902. So and you will be able to modify your resource on fly. So it means you send some manifest, it will be mutated and before storing in the etcd, and after that it will be stored in the etcd with all necessary changes. For the mutation, I'll show you how this works. For example, for the patch strategic merge, I will add some metadata, label, and owner. So this owner is actually wrapped with the scopes and this plus symbol. It's called anchors in the Kyverno stuff. Let me show you how it looks. It's allows you to perform some additional logic. Yeah, for example, these scopes and plus means that the tag will be added if not present. For example, this one will be added, like it means like the whole patch will be applied if the field exists and equals to the value. For example, this one, not this one. Just a second, I think I lost it, but it's exception. Okay, I used here a little bit different mechanism, but let me show you on their example how this looks like this. Yeah, so this policy will be applied, mutation policy will be applied once the secret is updated. It will apply the patch strategic merge, but not to the secret itself. So in the mutation, you are able to perform the patch for the resource that is actually changed or to already existing resource. So in this case, I will point the target some deployments. And then I perform the patch of this deployment. So I will add some metadata field. And also in this patch, I use such construction. So this global anchor means like apply the whole patch if this name field exists and equals like to some specific value. So as value, we refer to the object metadata name. So the name of the secret that was changed. So it means we can just describe it if deployment has some environment variable that use secret that was changed. So in this case, perform like adding of the annotation with some random stuff. It means every time when you change your secret, the deployment that use that secret will be automatically restarted. I'll show you the two examples here. Actually, for the mutation stuff, it's also important. Just a sec, number 2. For the mutation stuff, you can use also the wildcards if needed. But one important thing related to the mutation rules, if you have mutation rules, you are not allowed to use the wildcards in the match condition. So you cannot use like such approach like this. Yeah, so the wildcards are not allowed in case of the mutation fields here. So actually, it's a bad example. It won't work like in the right way. So the right example will be using the preconditions. So in case of the preconditions, it doesn't matter if which kind of rules it is, you are able just like to make the verification uh, with the wildcards without any kind of limitation. Actually, it's a good stuff, like to do not select the names or namespaces in the match section and perform all of these actions in the precondition. So in this case, it will work for any kind of rule. One more cool feature of the here we are. This is another example of the rule with a global anchor. So I check if my deployment in my specific namespace contains the image that starts with some specific registry name. So in this case, if this condition will be matched, in this case, my specific image pool secret field will be added. Also, there is ability to use another kind of conditions. Just a sec, I'll find it. Number 4. Yeah, here we are. So in this case, I use just only the scopes. It means if I have some secret keyref with name that is equal to this value, so I will perform this patch. But the difference is that once you perform this strategic merge, and for example, if you have the multiple items in your array, so in this case, like if you will use it in such way, it will probably override the whole array with just only one single element. But in such way, it will work only for the specific item. So it's like some trick. Like to understand how it works, you are probably will be need to play with the different anchors. What else? The patch strategic merge. So JSON patch is pretty straightforward. So it works in the same way like in the customize. But on this example, I actually want to demonstrate you that the mutate field allows you to use the for each construction. So you will be able to use the list here, then add the reference to the variable that contain actually specific list. And this operation will be applied to every element of this list. So this list will, inside of this template, it will provide two variables. It's the element index, and also it provide only the element. So for example, you will be able to refer to the container image in such a way. But in our cases, we use the 6902, so we need to use the index number. So for each container, we will add the run as non-root value under the security context. So it's the basic example. One more rule here. Probably this is not interesting. Just a sec. This is not interesting. Okay, let's take a look on the those two specific policies. So in this policy, So this policy will automatically patch my deployment once some secret will be created, and this secret match this specific pattern. So my deployment will be automatically patched, and I will add this credential to the source of the environment variables. And as I also add the random annotations here, so in this case, my deployment will be automatically restarted. Like it's how the auto mount can be implemented. The auto update, you remember, like you can just use a little bit different example here. Yeah, so you can just perform the patch for each container and just check if it use this secret. If it use this secret, so in this case, this container must be restarted because this annotation field will be updated. So one more resource, it's the policy exception. For example, I have the auto mount secret policy number three, like this. This is my policy. So I select the policy, select select the policy, select the set of the rules from my policy, then select a set of the resources that will be applied and some condition once my rule should accept this resource. So in this case, the exception will be applied to the secret resource that is called start name of this resource start with the credentials. And this resource has the label of the mount that is equals to false. So once I will create just a simple credential secret that starts with the credentials, it will be after mounted. If I will create the secret that contains the label, it like the policy won't be applied to it. It's how the exceptions work. So the condition here actually works in the same manner like a preconditions. And the last thing, it's the cleanup policy. So the cleanup can be on the cluster level or on the namespace level. So in my case, I add the match rule here. So it will select all of the deployments that can remove label with value true. And additionally, this deployment has more than 3 replicas, 3 or more. And I add some cron expression here. So this rule will be evaluated every 1 minute. So let's try to apply all of them and check how it works. So the first set of the rules here requires the label purpose team. So I will try to apply this this policy. Apply this policy. It's working one. Okay, so it's applied. Now, based on that, I want to create some namespace that matches like I want to create the namespace. Actually, the precondition is missed here, so I just need to add it. namespace create. Yeah, these names missed here, so I will just add it here. Make the apply of my policy one more time. So now when I want to create my namespace that starts with a team, for example, team B. Yeah, I see that the Kyverno sent me the error. And actually the error message, actually that I configured here, I see it here. Yeah, so now if I want to create this namespace, I need to create it together with the label. So I already have some resource here. So it's, for example, team E and with already presented label here. So once I will make the kubectl apply ls. So in this case, my policy is successfully, my namespace is successfully created. And after that, all of the rules will be applied. So in this case, the owner field will be added. So this field actually is built from the name of the namespace. So it will just trim the team suffix and just leave the second part. So if I will take a look on the set of the namespaces, here we are, team A. I already see that my label was added here. Beside that, I have the generate rule here. So the generate rule, you remember, it allows you to generate some portion of the resources. So in this case, I will generate some config map. So the resource can be generated or it can be cloned. So for example, you can just clone the resource from specific namespace. Yeah, so for example, you have some credentials in some basic namespace and you want to automatically populate it with to the new namespaces. Probably you can use it like, from my experience, we used some tools like Reflector, but in case of the Reflector, it still requires some manual changes, and reflector itself consumes a lot of the resources. So in this case, if you use the reflector somewhere for the automation, you can replace it with a Kyverno. Actually, it's a joke, but you can. If so, no needs to use it both. So just use something similar. So I generate the common config map. So let's verify if this config map is presented. Team A, config maps. Yeah, here we are. So it's presented and it contains my data. And deny team and as deletion. So as I'm a user of the cluster admin role, so I will be able to delete it. So probably delete namespace team A. I think it can be done in such a way. So I can just perform this. But if I replace this part, I won't be able to delete this namespace even with the cluster admin role. So based on that, you are able to define which user with which roles will be able to operate on your resources. So probably with RBAC, in some cases, you won't be able to limit. You can just allow, but you cannot limit your users. So I think if you will introduce it, like the Kyverno in your clusters, everybody will hate you. So this is the first policy. The second policy is called new workload. So it's denied the latest stack, but just only for the audit purpose. Add workload label, just add the owner label set image pool policy to always, and add some specific security context. So in my case, I already have the resource that is placed here. It's deployment. So I'll just apply it. Do and -F. Resource says deployment. Okay, and deployment is created. So once I will take a look in my team A and to my deployment, I see error image pool. Why? Because my image here starts with the some specific prefix. So it means that this rule about the pool secrets was applied. So I want just to, let's make a quick change here. So I will just replace this and apply it back. So in this case, okay, so my deployment starts. So my deployment has the appropriate label. It has context security policy, I think. Yeah, security context. It has image pool secrets. And so probably something wrong with my rule here for the content security policy. List objects, path, spec containers. Yeah, it's a little bit wrong here because I need to use use it in a little bit different way. I just need to add here template, spec containers, and then just apply this rule. Working. Here we are. So after some time, like this policy will be validated and like will be applied to my deployment and add the appropriate fields. What else? I think that's all. Then after mount secrets, let's take a look on this policy. I think it's already applied in my cluster, so I can just create some specific secret kubectl creates secret generic credentials test one, for example, in my namespace team E and add like some dummy data. And let's take a look on the set of the pods here. Okay, I added my credentials, and as you can see, so my pods started to reload, and as you can see, like in the environment variables, it's already provisioned. There is also the policy that's automatically restart if my secrets were updated. So I want to update my secrets here. Here we are, credentials. So for test data, let's generate something dummy. Test 2, base 64. Here we are. So I update my secret, and as you could see, I just updated it, and the pods already started to started to be refreshed test too. So it's in place. So let's probably omit the policy exception. So you can just try it by yourself. Let's take a look on the cleanup stuff. So I think this policy is already applied. So I need to add some deployment with greater than 3 replicas. So kubectl create deploy. For example, test 3, Nginx Alpine. -n team A. And I've seen replicas 3. Okay, so I created my deployment here. Okay, so it's in place. Now I can just I need you just to add specific label here. kubectl label deploy test3 -n team A. Can remove true. So I added this label, and after some time, like this deployment will be removed, like in 1 minute. Let's do not spend the time. I'll show you. So it works, but how to understand how it works, which set of the rules we have in the cluster, and etc. For this, there is a specific like sub-project of the Kyverno that is called policy report. So we will go to the policy reporter, and let's also expose it 8081. 8081. Yeah, so in the policy reporter, you will be able to see all of the rules and how they behave and which cluster resources or namespace resources are affected by this rule. Yeah, for example, Nginx deployment. So we can see all of the policies that were applied or skipped or probably failed for this specific resource. How to control like severity and how to manage this set of the dashboards. So for the policy, you can add some specific annotations. Yeah, so you can add the category. So this category will be displayed in the policy reporter. The name of the policies. Additionally, you can set the minimal version of the Kyverno and the Kubernetes version like to this policy be applied. And it's a good approach just to add the description for your policies. Why actually you need this? Because you can see that Kyverno itself provide of the set of the specific policies for different tools. Yeah, for example, for the Istio, like that automatically adds sidecar injection. So you won't be need to make it manually anymore. So just apply this policy, and it will apply this label to all of the existing and all new namespaces in your cluster. So, and like the same, for example, for the certificate manager and etc. So you can just validate it by yourself. If you actually don't like to use the CLI, there is an online playground. So in this online playground, you can just write your policy. For example, write your resource that you want to test policy against. And beside that, you can just like mimic some cluster resources. Just write these resources, and this policy validator will think that these resources are already in the cluster. So all policies that I demonstrated actually were prepared and tested with this playground. Let's verify if our deployment is presented here. No, it's not presented. One more thing probably that I want to point you. I think we don't have time. We have 3 minutes left, so I also want to spend some time for the questions. I'll show you what will be probably interesting for you. from the perspective of the like what to read. It's the variable support. So which variables are defined are existing in your templates, what you can use, how you can gather the information information like variables from different sources. For example, for policy definition, if you use such syntax, it will just go back for 3 levels, like 1, 2, 3. Go to the readiness probe, find TCP socket port, and just paste the value here. How you can escape the variables, mission review variables, what is also interesting, from the image registry. So if you like use some image verification, so in this case you will be able to use this images variable and gather this this basic information and use it in your template. Also, you are able to define the inline variables or use the variables, for example, from the config maps. Just a sec. I think you can. Just a sec. Yeah. For example, here you can in your rule you can define the context with all set of your variables that you want to use in the template. For example, you define this context and gather all of the variables from the config map. So in your template, you can just refer to this data like using this standard syntax. And beside that, you are also allowed to use the external sources. What means by external sources? So beside the config map, you are able to gather the information directly from the Kubernetes by examining the API servers. For example, like you can define the variable that will show you the amount of the pods in the namespace. So just use the standard Kubernetes API URL, paste the namespace name from your request, and then apply the GMS pass transformation, like gather the items from the response from these queries, and then calculate those lengths. And this like variable, you will be able to use it in your templates. And beside the Kubernetes API, you are also allowed to examine some third-party services. Yeah, so any kind of HTTP or HTTPS service, gather the information from there, apply like GMS pass transformation if you wish, and then use that variable from this context in your templates. What's to read next? So I strongly recommend you to check the variable stuff and verify images rules. So we don't have like enough time for this, but the verify image rules are very interesting topic to deep dive in. Also check the Kyverno JSON sub-project. So if we use, like for example, the open policy agent was developed as the policy mechanism for any kind of data, and after that they provided the gatekeeper that used the open policy agent to apply everything to Kubernetes. So in the case of the Kyverno, it's vice versa. So the Kyverno was created for the Kubernetes, and based on the Kyverno, they created the Kyverno JSON sub-project. It's like it's a simple command line tool that allows you to apply the Kyverno policies to different type of data. For example, with the Kyverno, you can just can validate the Docker files, Terraform. So anything that are probably structured can be validated with the Kyverno. I think that's all. Let's start with the questions. Okay, let me open the chat. Uh, okay. Okay. So here is only the gratings. Any questions?
I have. May I?
Yeah, sure.
Probably you know that the latest Kubernetes version shipped with new admission controllers like validating and mutating admission policies. So I have not used the Kyverno and that policies, so maybe you familiar with them, so maybe you can shed some light if for example they can cover some functionality of Kyverno and we can use for example simplest task that admission controllers instead of Kyverno.
So the Kubernetes, like traditionally, so Kubernetes doesn't provide the solution. They provide like the ability to extend these. So the admission, webhooks, and etc. It's just ability like to redirect your requests to some third-party tools. It's like the CNI interfaces, CSI interfaces. So the same with admission stuff.
I mean the policy instead of webhooks. So there is down validation admission policy, but it seems you are talking about a webhook.
Sorry, didn't get you.
Okay, I will send a message in the chat right now.
Yeah, sure. So in the meantime, any other questions?
Yeah, maybe I'll have like one question, not like strictly connected maybe to the topic, but I'm kind of interested in like how the Copilot like do it like with all the YAML files. Like, have you used it and maybe like did some prompts that are helpful in writing the files or maybe fixing some errors?
I think the Copilot will works fine. So like to verify, you can use the playground stuff, but like I think we can just validate these. Let's check. I don't know some specific.
Yeah, I mean like it just like from your experience. I mean because like
No,
if you're talking
I
like about
hadn't used it. So actually,
okay,
I don't use Copilot at all. So I just trust
okay,
myself.
got it. Yeah,
But
because
I
yeah, the
think
question was like, yeah, if it's like simple like to write it by your own, or it's better like to use Copilot because sometimes it just take so much time like to guess the right prompt.
check. So probably something like this. So I think like it's a very dummy version of the chat. I think ChatGPT will work better when even the GitHub Copilot will work better because it's I think it's consumed some amount of data from already existing projects that actually use Kyverno. So
Okay,
probably
got it.
it will
Thanks.
work for you.
Thanks a lot.
Okay. Okay. Mutation admission policy. Ooh, actually, I hadn't chance to use these. Probably, let's check. I think I hadn't chance to use these. Probably this can be used as replacement, but what I'm worried about it's like that it's like in alpha support. Sometimes happens that they provide this feature with alpha support, and after that they just after some versions they just replace it, something like that. But from here, what I see, they use like the only common expression language here. So I think the possibility of this mechanism is pretty limited. And actually, it supports only just mutating and probably validation admission policies, but there is no generation, cleanups, and etc. So it's like it can be used as solution, on my opinion, but I'm not sure if it just can cover 100% of the Kyverno functionality. Any other questions?
Looks like we don't have any
It's like,
questions.
nope. So everybody is tired. Sorry for that. I just over time for the 10 minutes.
It's okay.